The recent transmission of the highly pathogenic avian influenza virus H5N1 to cattle raises serious concerns about its evolving nature and the growing risk of a future pandemic. While this virus has been known for decades as a lethal threat to birds, its expansion into mammals, particularly livestock, signals a dangerous shift. The situation unfolding in the United States, where H5N1 has been detected in dairy cattle, highlights the virus's ability to adapt and find new pathways for infection, potentially increasing the risk of human exposure. One of the most alarming aspects of this development is that the virus is spreading in dairy herds not through respiratory transmission, as typically observed in avian outbreaks, but through contaminated milking equipment. This suggests that viral particles are present in raw milk, raising concerns about its potential role as a transmission vehicle. While pasteurization effectively kills the virus, the presence of H5N1 in an agricultural commodity consumed globally adds a new layer of risk. If the virus were to mutate further and gain efficiency in mammalian transmission, it could pose a serious health threat beyond the agricultural sector. Although the number of confirmed human cases remains low, a study conducted in Michigan suggests that exposure rates among workers in infected farms could be higher than previously thought. The detection of viral antibodies in nearly 7% of those tested indicates that silent infections may be occurring. This is particularly concerning because mild or asymptomatic cases could go undetected, allowing the virus to spread unnoticed. Historically, influenza viruses have proven their ability to mutate and adapt, sometimes acquiring the capacity for sustained human-to-human transmission. While H5N1 has not yet reached this stage, its persistent spread among mammals makes such a scenario increasingly plausible. The scientific community remains cautious but watchful. Experts stress that constant surveillance and genomic tracking of H5N1 are essential to detecting mutations that could facilitate its adaptation to humans. The parallels to past pandemics, such as the emergence of H1N1 in 2009, are a stark reminder of how quickly a virus can shift from an animal reservoir to widespread human transmission. Unlike seasonal flu strains, H5N1 has demonstrated an extraordinarily high mortality rate in human cases, exceeding 50% in past outbreaks. If the virus were to acquire the ability to spread efficiently between people while retaining its high pathogenicity, the consequences could be catastrophic. In response to the growing threat, research efforts have intensified to develop vaccines and antiviral treatments. While existing antiviral drugs like oseltamivir and baloxavir have shown effectiveness against H5N1, their impact would be limited in the event of widespread transmission. The push for a universal flu vaccine capable of protecting against multiple influenza strains is more urgent than ever. However, such a breakthrough remains years away from practical implementation. In the meantime, biosecurity measures in the livestock industry must be strengthened to minimize cross-species transmission, and governments should be proactive in funding preparedness efforts. Beyond the immediate concerns in agriculture and public health, this outbreak exposes broader vulnerabilities in global pandemic preparedness. The COVID-19 pandemic underscored the devastating consequences of underestimating an emerging pathogen. While lessons were learned, the current response to H5N1 remains fragmented. Many countries still lack comprehensive surveillance systems for zoonotic diseases, and international coordination in tracking viral evolution remains inconsistent. Given the unpredictable nature of influenza viruses, the world cannot afford to be complacent. The presence of H5N1 in dairy cattle should serve as a wake-up call. The more opportunities the virus has to replicate in mammalian hosts, the higher the chance that a mutation could spark a new health crisis. This is not just a problem for the agricultural sector, it is a potential public health emergency in the making. The scientific consensus is clear. We must act now to contain the spread, invest in research, and prepare for worst-case scenarios. The longer we delay, the greater the risk that H5N1 will make the jump we all fear, a shift to sustained human transmission that could usher in the next pandemic.